My research began with the intent of reducing energy consumed by buildings with a focus on air conditioning efficiency because they are major energy drains. I envisioned a cooling system that aligns building performance with human comfort needs, a system that could redefine how India cools its buildings. And PMRF played a pivotal role in transforming this idea into reality. I developed a novel strategy for smart air conditioning called micro-zonal occupant-centric control. This is two parts. First is designing microzones considering the functional and spatial aspects of a space, and second is occupant centric control, which optimizes airflow patterns in a space. Here's a brief pictorial representation where there's a smart MZOCC system which can detect occupancy, understand the indoor thermal conditions, and understand the thermal preferences of occupants, and direct the operation of diffusers in occupied as well as unoccupied regions to create micro comfort zones around occupants. The idea is that MZOCC cools the people and not the room. And because this uses standard HVAC diffusers with minor additions, it requires low investment. And it uses AI based self learning modules to understand the thermal preferences of occupants and customize cooling around occupants. MZOCC is grounded in Indian markets' technical and economic realities. It has been tested for 6 offices in India and can yield at least 60% energy savings with just 10% additional investment. I've published 14 papers on this and I've also applied for 2 patents in India. Today, I'm continuing this journey as a postdoctoral fellow in Stanford University, where I'm receiving training and funding to commercialize MZOCC. My goal is to develop versions of scalable and affordable MZOCC for public and private sector buildings in India and help India move closer to its net zero energy targets. Here I'm showing a small prototype or a demo on how the advanced airflow strategies that I've developed works in containing cool air in a region and increasing the spread of air jets so that the occupied region is comfortable. There are challenges which leads to convergence of air jets. One such challenge is when the distance between the diffuser increases, more advanced airflow strategy needs to be there in order to avoid convergence of air jets. I've developed strategies called setback flow and setback temperature, which can be used in order to improve the air distribution inside the space. Another challenge is that while maintaining setback temperature, if diffusers are placed very close to each other, cool air can escape without reaching the occupants. And this challenge I've addressed by using the first level of protocols, which gives directions on how diffusers and furniture needs to be arranged in order to create comfortable micro comfort zones. So that's the bi-level protocols.